If you've ever watched someone glance at something complicated for a few seconds and somehow already understand it while you're still on the first page. If you've assumed they must just be smarter, or wired differently, or born with something you weren't. Welcome. The research on this is stranger than smarter, and honestly more useful. Or maybe you know someone like this, the coworker who opens a new piece of software and is fluent in it by lunch. The friend who looks at a chessboard for a few seconds and can describe the whole position later. The student who reads something once and seems to just get it, while everyone else is still rereading the same paragraph. If someone just came to mind, here's the first surprise. It's almost never memory. It's something else entirely. Researchers tested this decades ago with chess. Grandmasters looked at a real game position for 5 seconds and could recreate almost the entire board afterward. Beginners remembered a handful of pieces at best. It looked like photographic memory. Then, researchers ran the same test with pieces arranged randomly, positions that couldn't happen in a real game, and the grandmaster's advantage almost disappeared completely. They weren't remembering pieces, they were remembering relationships. A real position had structure they recognized, a random one didn't. This is called chunking, and it's the actual engine behind fast learning. Working memory can only hold a handful of things at once, somewhere around 7, often fewer. Beginners spend that whole budget on individual pieces. A musician doesn't see 3 separate notes, they see one chord. A programmer doesn't see individual symbols, they see one loop. Experts aren't holding more information in their heads, they're holding fewer, bigger units, so the same limited memory suddenly covers a lot more ground. Here's the part that sounds backwards. Fast learners aren't remembering everything. They're forgetting on purpose. The brain constantly strips away the specific details of what you experienced so it can keep the pattern underneath. Someone learning a language doesn't memorize every sentence they've heard, they extract the grammar and let the individual sentences go. Learning was never about storing more. It's about compressing what you already have into something simpler. So why does one person do this faster than another? Because the answer isn't raw intelligence, even though that's the assumption almost everyone defaults to. The psychologist K. Anders Ericsson studied elite violin students at a music academy in Germany and found the best ones weren't distinguished by natural gift. They accumulated more hours of a very specific kind of practice. Hours spent attacking their actual weaknesses with immediate feedback, not just repeating what they already knew. Beginners tend to practice the parts they're already good at, because it feels productive. Experts isolate the 4 notes that keep tripping them up and drill exactly those, over and over, until the weak spot disappears. Now here's the part almost nobody catches, and it's the twist that flips how most people try to study. Easy learning is often fake learning. Educational psychologists have a name for the trap: the illusion of mastery. When something feels smooth and effortless while you're doing it, rereading a chapter, watching a tutorial a second time, that ease feels like proof you understand it. It usually isn't. It fades fast. What actually builds lasting understanding is closer to the opposite feeling: the uncomfortable effort of trying to pull an answer out of your own memory instead of having it handed back to you. Researchers call this the testing effect, and it's one of the most consistent findings in the field. Struggling to remember something strengthens the memory more than reviewing it ever does. If studying feels easy, that's often the warning sign, not the reassurance. Fast learners also tolerate something most people run from, which is confusion itself. Beginners tend to panic the moment something doesn't make sense and go looking for an easier explanation. Experts expect the confusion and treat it as part of the process instead of a sign they've failed. Some of the strongest learning happens when people wrestle with a hard problem before anyone teaches them the clean solution. Because the struggle builds a kind of mental scaffolding that the clean explanation later snaps onto. Curiosity itself seems to prime this process. Researchers have found that when people get genuinely curious about an answer, Their memory improves not just for that answer, but sometimes for unrelated things they happen to learn around the same time. As if curiosity puts the whole brain into a more absorbent state. Confusion isn't the wall. It's the doorway most people turn away from. There's also a strange asymmetry in how fast learners treat their own mistakes. Neuroscientists studying prediction found that the brain updates itself most when reality surprises it. No surprise, no update. A wrong guess corrected on the spot teaches you more than a right answer ever could. Because the right answer just confirms what your brain already assumed. Fast learners tend to guess before they're told the answer. On purpose. Specifically so they have something to be wrong about. Which means the real question isn't, am I smart enough to learn this quickly? It's whether you're spending your effort on the right kind of difficulty. Some difficulty is worth chasing on purpose, testing yourself before you feel ready, mixing different types of problems together instead of drilling one at a time, explaining an idea out loud in plain language to expose the parts you're actually fuzzy on. Some difficulty is just noise, rereading the same material hoping it sinks in eventually, or avoiding a topic because the first attempt felt confusing. And some difficulty needs to be sought out deliberately, the parts of a skill you're quietly avoiding because they're the ones you're worst at. Intelligence analysts are trained to do something similar with their own thinking. Instead of collecting more evidence for what they already believe, they're taught to actively hunt for whatever would prove them wrong. Fast learners do a version of this without being told to. They don't just ask, "What did I learn today?" They ask, "What am I still getting wrong?" And they go looking for it on purpose, instead of waiting to be embarrassed by it later. Here's the recalibration. Before you look something up, guess the answer first, even if you're probably wrong. After you read or watch something, close it and try to explain it out loud in the simplest words you have, and pay attention to exactly where you get stuck. Mix your practice instead of blocking it. Don't drill the same type of problem 20 times in a row. Switch between 2 or 3 related ones so your brain learns to tell them apart. And when something finally starts to feel easy, treat that as a signal to test yourself again, not a signal to stop. This kind of learning leaves a physical trace, not just a mental one. London cab drivers used to have to memorize around 25,000 streets to earn a license, a process called simply the knowledge. Brain scans of experienced drivers found a larger hippocampus than average, the region tied to spatial memory. The learning didn't just sit in their heads, it reshaped the structure holding it. The fastest learners were never storing more information than everyone else. They were building better shelves to put it on. And they were willing to feel confused for longer than most people can tolerate before the shelves finally clicked into place. Subscribe and watch this video next.